Our cosmic curiosity, the call of the cosmos. Ever looked up at the night sky, past the city lights, into that deep dark ocean above? What did you see? Countless stars. Maybe a planet shining steady. The moon, our old familiar friend. It pulls at us, doesn't it? This vastness, this mystery. We are, after all, stardust, made from the same stuff. Ancient civilizations charted the stars. They built monuments aligned with cosmic events. They told stories about constellations, gods and heroes written in the sky. Why? Because space is inspiring, it's humbling. It reminds us there's something bigger than our everyday lives. This curiosity, it's fundamental to who we are. It's the engine of discovery. Space exploration, it's not just about rockets and astronauts, it's about that deep, ancient yearning. Let's explore it together. The Great Space Race, a rivalry reaches for the sky. How did we actually start going to space? It wasn't just pure curiosity at first. Politics played a big role. Picture this, the mid-20th century. The world was divided. The Cold War, two superpowers, the United States and the Soviet Union. They competed in everything. Arms, ideology, influence. And then, a new arena opened up. Space, the final frontier. This intense competition became known as the space race. It was about national pride. It was about technological superiority. Who could get there first? Who could plant their flag, metaphorically or literally? The stakes felt incredibly high. The whole world was watching. Every launch, every test was front-page news. It was a dramatic time. The space race, for all its political baggage, lit a fire under our cosmic ambitions. First orbits Sputnik, Gagarin, and Shepard take flight. October 4, 1957, a date that changed the world. The Soviet Union launched Sputnik 1, a small, polished metal sphere, about the size of a beach ball. It had a simple radio transmitter. Beep, beep, beep. Those beeps were heard around the globe. It was the first artificial satellite, orbiting Earth. The space age had officially begun, and the Soviets were winning. The Sputnik crisis shook America. NASA, the National Aeronautics and Space Administration, was born in 1958. Its mission to catch up and to lead. But the Soviets weren't stopping. They sent the first animal into orbit, Laika, a brave dog, in Sputnik 2. A one-way trip, sadly. But it proved life could survive launch and weightlessness. Then came the ultimate Soviet triumph. April 12, 1961. Cosmonaut Yuri Gagarin, a young, charismatic pilot. He climbed into his Vostok 1 capsule and became the first human to orbit the Earth. "Poyakali," he said. "Let's go." He saw our planet from above, a beautiful blue sphere. No borders visible, just one Earth. One giant leap to the Apollo program and the moon landing. The space race needed a grand goal, something audacious, something that would capture the world's imagination. President John F. Kennedy provided it. In 1961, he stood before Congress and declared, "I believe that this nation should commit itself to achieving the goal before this decade is out, of landing a man on the moon and returning him safely to the Earth." The moon, our celestial neighbor. It seemed impossible, but the challenge was set. The Apollo program was born. This was an undertaking of epic proportions. It required new technologies, new materials, new ways of thinking. Hundreds of thousands of people were involved. Scientists, engineers, technicians, factory workers. The Saturn V rocket, the most powerful machine ever built. It stood taller than the Statue of Liberty. Its engines generated 7.5 million pounds of thrust. Imagine the noise, the power, the sheer ambition. There were setbacks, tragedies like the Apollo 1 fire, but the resolve never wavered. July 20th, 1969, Apollo 11, Commander Neil Armstrong, Lunar Module Pilot Buzz Aldrin, Command Module Pilot Michael Collins. The lunar module, named Eagle, descended towards the moon's surface. The world held its breath. "Houston, Tranquility Base here, the Eagle has landed." Those words, chills even now. Section 5, Robotic Pioneers, our mechanical envoys in the solar system. Sending humans to space is hard. It's risky. It's expensive. Humans need air, water, food, and protection from radiation. But what if we could send explorers that don't need all that? Enter our robotic pioneers, probes, landers, and rovers. Our eyes, ears, and hands across the solar system. They are tireless. They are resilient. They can go places too dangerous or too far for humans, at least for now. Think about the Voyager probes, launched in 1977, Voyager 1 and Voyager 2. Their mission, a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. They sent back stunning images, revealed new moons, rings, and storms, and they carry golden records, messages from Earth for any aliens who might find them. Now, decades later, both Voyagers are in interstellar space. They've left our solar system's bubble, humanity's farthest emissaries, still phoning home. And then there's Mars, the red planet, our neighbor, our obsession. Could there be life there? Section 6. A home in orbit, the International Space Station. After the moon race, the focus shifted. How can humans live and work in space for long periods? We needed a laboratory in orbit, a permanent outpost. The answer? The International Space Station, or ISS. It's a marvel of engineering, and a triumph of cooperation. Think about it, multiple countries, former rivals working together, USA, Russia, Europe, Japan, Canada. Building this massive structure piece by piece in space, it's like a giant orbiting Lego set. The ISS is about the size of a football field. It zips around Earth every 90 minutes. Astronauts on board see 16 sunrises and 16 sunsets every day. Imagine that view. Our beautiful planet constantly changing below, but it's not a vacation spot. It's a working laboratory. Scientists conduct experiments in microgravity. Things behave differently up there. Fluids, flames, crystals, even our own bodies. These experiments help us understand fundamental science, and they can lead to breakthroughs on Earth. Living on the ISS is a unique challenge. Astronauts exercise for hours every day to combat muscle and bone loss. They grow plants, they fix equipment. Section 7. Eyes on the universe, telescopes, and unveiling cosmic secrets. How do we know so much about distant stars and galaxies? Things we can't possibly visit yet. The answer: telescopes. Our eyes on the universe. For centuries we used telescopes on Earth, looking up through our atmosphere, but the atmosphere blurs and blocks some light. It's like trying to see clearly through a rippling swimming pool. So, what's the solution? Put telescopes in space above the atmosphere, a crystal clear view. The Hubble Space Telescope, launched in 1990. It revolutionized astronomy. It showed us the birth and death of stars. It captured stunning images of nebulae, cosmic clouds of gas and dust. It helped us determine the age of the universe, about 13.8 billion years. It found evidence for supermassive black holes at the centers of galaxies. Hubble has made over 1.5 million observations. It's an icon of science, a window to wonders. It needed some eyeglasses early on due to a flawed mirror, but astronauts fixed it. And now, we have the James Webb Space Telescope, JWST. Launched on Christmas Day 2021, it's Hubble's successor, bigger, more powerful. It sees in infrared light. Section 8, the next frontier, Artemis, Mars, and beyond. So we've been to the moon, we have robots all over the solar system, we have amazing telescopes. What's next? The human desire to explore doesn't just stop, it grows. The next giant leap? Many believe it's Mars, but first, a return to the moon. NASA's Artemis program aims to do just that, land the first woman and the next man on the moon, this time to stay, to build a sustainable presence, a lunar base, a gateway in lunar orbit. Why go back to the moon? It's a proving ground, a place to test technologies for Mars, like habitats, life support systems, rovers. The moon has resources too, water ice in shadowed craters. That water can be used for drinking, for air, and for rocket fuel. Imagine refueling your Mars-bound spacecraft at a lunar gas station. The moon is just 3 days away, Mars is months, even years. It makes sense to practice closer to home. Artemis involves international partners and commercial companies, a new model for space exploration, and then Mars. The red planet beckons, the ultimate goal for many, to see human footprints on Martian soil. It's a huge challenge, the journey is long. Radiation in deep space is a danger. Landing safely on Mars is tricky, it has a thin atmosphere. And then, living there, creating a self-sustaining outpost, growing food, producing oxygen, protecting against dust storms. Section 9, Why we explore, the enduring quest for knowledge and survival. So, why do we do it? Why spend billions of dollars, take enormous risks? Why reach for the stars? Is it just because it's cool? Well, it is cool, but there's more to it than that, much more. Space exploration benefits us right here on Earth. Think of the technologies: GPS, satellite TV, medical imaging like MRI and CAT scans, weather forecasting, memory foam, scratch-resistant lenses, cordless tools. Many of these came from space research, spin-offs. Necessity is the mother of invention. Space is a demanding environment. It inspires us, especially young people. It encourages students to pursue science, technology, engineering, and math, STEM. We need those bright minds to solve Earth's problems too. Climate change, disease, resource scarcity, the challenges of space push innovation. They teach us how to live sustainably in closed environments. Lessons we can apply right here on our home planet. It gives us perspective, that overview effect, seeing Earth from space, a fragile blue marble alone in the void. It makes political squabbles seem pretty small, doesn't it? Space exploration is an investment in our future. It's about understanding our universe and our place in it. Are we alone? It's one of the biggest questions humanity can ask. Finding life elsewhere, even microbial life, would be revolutionary. It would change everything. And what about the long term?